All right, so with that, I would like to introduce our panel today. Now, these are some of the folks I get to work with on a daily basis here at Google, and it's a great environment. But today, you will also get to meet them in case you haven't already, and interact with them. So we have Megan Golick, who is in charge of everything within the HPC team, but I will let her give you a quick intro.
Perfect. Hi, everyone. I'm Megan Golick. I help lead our outbound presence in terms of events, marketing, press blogs, others, as well as a handful of other activities here. So it's great to see everyone.
All right. Next, we have Wyatt Gorman, who I'm sure many of you are familiar with, and Wyatt is, a central knowledge repository. So I'll let him give his own introduction.
Hey folks, my name is Wyatt Gorman. Thanks, Adnan. I'm a product manager at Google Cloud working on high performance computing. Been with Google for about 8 years. And yeah, I help build solutions for customer challenges in high performance computing across the industries.
All right. And last but not least, we've got Annie Ma Weaver. Annie?
Thanks, Adnan. Hi, everyone. I'm Annie Ma Weaver. I'm a group product manager on the same team as Megan and Wyatt. I've been with Google for almost 16 years, which means that I joined as a baby. And then I cover financial services, Slurm, GCP, HPC, VM, Image, and a number of other initiatives. Very happy to be here.
All right. Thank you very much to our panelists. Again, you've got a lot of expertise in front of you today. And also helping us behind the scenes is Mary Garza, who I'm sure many of you are familiar with. So thank you very much, Mary. All right. So having said that, I did say that today is going to be a different session, an unusual session. So we've got a set of questions that we've curated and put together, and I'll present that to the panel to get their opinion. And they're going to be generally about, how we see HPC evolving, how is AI coming into the picture, and so on and so forth. But as much as I want to hear our panel's opinion, I also want to see what kind of questions you have. That is the audience. And just as a reminder, this is open to everybody. So for those of us from Google, I just want you to be mindful of the fact that we have external people present over here. So please do not discuss anything that's confidential or not publicly released as yet. All right. So with that in mind, I'm going to go ahead and really sort of, start today's session. Okay, so the question is, we see a lot of talk about this convergence of HPC and AI. Now, for many in the audience, you probably read a lot about it as well. But I'd like to start with our panel and really ask what does this really look like for a cloud customer today? So let's start off. I'll try to go alphabetically through our panel and wait for our audience to also chime in. But Annie.
This is what I get for getting an A name. Yeah, so I'd say it's definitely deeper. So let me use my lens of financial services to answer how I'm seeing this with customers. We have a number of capital markets customers who are now using AI to identify algo candidates that they want to then run a more standard traditional HPC workload, like a Monte Carlo simulation on. But that initial identification of candidates, much like a biomolecular workload, drug discovery workload, that initial one is now being driven by these models that they are using off the shelf and then customizing. So we actually are working with them on a number of AI-related initiatives to feed into their HPC workloads. We're also seeing a lot of interest in using different accelerators, and so GPUs, but also TPUs. And for TPUs, we're getting a lot of questions about what kinds of backends or model frameworks are best. We have PyTorch, we have JAX. Customers don't want to have both running, and so more and more as an HPC product manager, I'm being asked to not just be up to speed, but really on the leading edge of these AI solutions, hardware and software that our customers want to use, and integrating that into their HPC flow.
All right, thank you, Annie. So Megan, you get to go next.
Yeah, no, I think AI is really making HPC smarter. And I think that goes much deeper than what's here in the question here. I think it's making it smarter faster, and it's making kind of the HPC user just more productive in general. And we've seen a lot of that. I mean, and I know you and I've kind of joked around of playing with some of our other tools between Gemini Enterprise, Gemini CLI, and some of these other things to really see how we can make the HPC workflow itself easier and smarter. And so there's tools like that. So I think, you know, there's always the age-old debate of is AI an HPC workload, but I think it's actually AI in the HPC workflow and how it's making us be much more efficient and just get to insight faster.
All right. And Wyatt, you know, you've been looking at this space for a very long time. You know, how do you see it coming in?
Certainly not as long as some folks on the call. So I definitely come at it with a few different perspectives. I think it starts with fundamental technology, right? There's a lot of similarity between HPC technology and AI technology. AI kind of being born out of HPC, but I think it's taking the trajectory that sort of Hadoop did, where it started as an HPC type workload, ran on a lot of HPC hardware, but then sort of split off into its own discipline. We see a lot of that with some recent acquisitions and mergers. SketMD just bought by NVIDIA, right? And there's a lot of debate within Google about whether that was an AI acquisition and investment or an HPC one or both, right? And I think it was clearly both. So there's a lot of similarities in the technology. I think there's a lot of similarities in the use cases, right? The problems being solved. So you know, protein folding is maybe a good example where now we have things like AlphaFold that are an AI-based solution to that problem, where that problem would have taken, you know, a researcher years to solve. Right now, it's solved very quickly. But I also think it's integrating AI and HPC workflows. Right, so AlphaFold now becoming part of the workflow in you know, a drug discovery use case where the results of AlphaFold might pump into a full molecular genomics simulation or go on to inform more complete and full precision simulations. And then at the same time, I think there's some replacement of you know, traditional HPC solvers with AI techniques. So yeah, I think it's sort of multi-tier.
All right. So anybody in the audience, would you prefer to comment on how you see it changing, or is it really being integrated? You can, so if you'd like to speak, you can also use the icon in your icon bar at the bottom. There's a little hand or a palm. You can click on that, and that'll let us know that you'd like to speak. So is there anybody in the audience who would like to quickly chime in on this question? And if nobody chimes in, I'm going to pick somebody at random. So, you know, yeah. You know what? I see one gentleman who is on video. Darmuid, would you like to offer a quick sort of an opinion?
Thanks for asking. Yeah, I mean, I'm something of a newbie, even though I'm in the industry a long time, so I wouldn't claim great expertise on HPC actually. But I do feel that it's important to look to the strengths of both HPC, which is well tried and trusted, and a lot of the AI stuff still has a certain amount of proof points that need to be done in the AI context, I think. So even though the questioner puts in the word just, is it just running AI and HPC infrastructure? I think it's reasonable to do it that way. That's really my point. That I think both arms of the activity, HPC and AI, have got lots of activity going on, lots of capital behind them, and so they're going to have to coexist whether one likes it or not. You know, so I think it's reasonable to run the two together, and I think, I mean, part of the reason why I'm here is that I think that having a lot of compute power by definition is going to help with AI jobs and clarify what would be successful AI jobs, as opposed to the stuff we're seeing a lot, which is really too focused on predictive text, to be kind of blunt about it.
Right. And hey, Darmuid, could you just give us a brief introduction about yourself and your background, so you know the community?
Well, I mean, I have something in the chat there. So I kind of was a quasi-Googler. I was in the extended workforce with Cognizant for 4 years, 2021 to 2025. And I was with Dell, and I joined Oracle when around the time Oracle had the acquisition of Sun, so I took an interest in their kit, like Exadata in particular. That's a quick summary.
Okay, cool. Thank you very much.
Thanks.
All right, so let's go, keep on moving. Let's go to the next question. And so with the rapid,
we have
And then we actually have a
Oh,
hand up.
of course. Hey, Tim, thanks for
Hey,
joining
Adnan.
us.
I couldn't help but I was going to sort of sit quietly in the background, but I just as one of those people with road miles, city miles, not highway miles in this space, I would say that over the last 20 years, we've always had this conversation. What about X or Y? What about supercomputers and vector systems versus cluster? What about on-prem versus cloud? But I think that even in the conversation around this, the question's always the same, or I should say it's the same problem-solving process. It's, let's not get too wrapped up in the technology. Let's step back and figure out what the problems are that we're trying to solve. Because the fact of the matter is that the way that this technology is going to get deployed, oftentimes there are very few of us that have a whole lot of control over how much and when we will get the resources that we get. So it's really more about how do we do the best that we can to make the most out of what we've got. And so I think that even as people are looking closely at HPC and AI, I do think quantum's a different beast because of the hardware platform, but so much of this is just going to be, how do vendors and their customers work together collaboratively to try to figure out what's the real problem to solve, and then back into that with the technology that's available. And then it's not even just about the compute side. If we can't get the storage issue addressed, then that other piece is moot. And so every time, the reason I came off mute was because each time I hear this conversation where people are talking about, well, what happens about the convergence or divergence or anything else, basically the same problem-solving methodology that's gotten us through the last 20, 25 years. And we can't get away from that. We actually have to stick to and double down on what that methodology was in order for us to get to the other side of this. Because getting to the other side of this is just going to reward us by having one more thing that we have to go figure out, right? So we might as well keep the muscle honed.
All right. And Tim, hey, just give us a quick background. I know you for a very long time, and I've never known you to not voice your opinion, so I'm really glad you did. So
Thank you.
But yeah, just give us a quick introduction to who you are. And
sure. Yeah, I've been around a while. I started with Linux Networks way back in the early 2000s, and then I ran Dell's HPC business. And then I left Dell. We did a company called Supercomputing, which was a software orchestration tool that we were fortunate to have been acquired by Microsoft at the time. And then I was at Microsoft through last year, principally in the Azure group, helping stand up the government side of the cloud HPC business. And so I've been through several technology shifts in this space, and still here and love it.
All right, great. Okay, cool. All right, so moving on, let's get to our next question. It's somewhat related to the previous one, where we talk about this convergence of HPC AI and now quantum, as Tim, that you also brought up. So how do we see this definition of supercomputing evolve in the next 3 to 5 years, or even beyond that, right? Because sometimes when you talk about quantum, you're talking about a timeline that goes beyond 5 years, and you're talking about maybe even 10 years. So Annie, I'd love to hear your perspective on this one.
Sure. So I think in many ways, this is the defining question for our product roadmap for the next 3 to 5 years. So it's a biggie, and I'll try to tackle it in a concise soundbite. I think supercomputing is going to evolve from being a noun of about being like machines in a data center in a basement to a verb, like a converged complex workflow. We're already seeing this in how Google is defining supercomputing as a service, cluster as a service. That was something. Oh, Bruce says I don't have any audio. Can other people hear me? Or
I can, yeah.
Yeah.
Okay, I'm sorry to hear that you can't. Uh-oh. Well, I was gonna offer you troubleshooting, but maybe yes, that works. Okay, so I think one of the things we're going to see is this idea of supercomputing as a flexible converged workflow rather than a static, hardware definition. And then for financial services and HPC in general, we're going to see HPC and AI break down the silos between the two. Like no longer will AI be a workload, HPC be a workload, but we'll see more and more AI as part of HPC. So I mentioned earlier, with a risk calculation or portfolio optimization, being able to identify candidates and then to run that. And in the future, in the next 3 to 5 years, it'll go even further. It's not only just what you're running your Monte Carlo simulations on, but how to run those simulations on which types of supercomputing clusters, when to run them, like optimizing not just the what but the how for our quants, so they don't have to think about infrastructure at all. They don't have to think about compute, storage, networking. They just think about the problem they're trying to solve, and then we as Google can meet them where they are. So that's one way. And then quickly on quantum, I think quantum is going to be a specialized, akin to a specialized accelerator for particular workflows. So I think we'll have supercomputing as a overall concept. And then within that, there is quantum available for specific types of problems that require it. And we will figure out portions of that with this group and with our customers over time. But I certainly see this as a very important question.
Okay, and I'm going to ask this question to everybody, but starting with you, Annie. So what do you think the time frame for quantum is? Just give us, a range. And this is for the audience as well. So if you think, when do you think quantum will be of practical utility? So just put in your the number of years, when in the comments section. So, but Annie, so would you like to offer
I think it might be some time. Yeah, I'm seeing a lot of guesses that I'm agreeing with. Like, I was going to say 5 years, like in an ambitious way. Of course, come back in 1 year, and I'm sure the world will have changed. But we have a number of benchmarks that we've published that show quantum's abilities on synthetic benchmarks or synthetic problems, but not real-world problems. And I think it's that bridging between the synthetic benchmarks and the actual use cases that our customers want and the commercialization of the quantum technology for them, that will take some time. So I would say conservatively, or even ambitiously, 5 years. And then hopefully I'm wrong, and hopefully it's sooner.
All right. So Megan, you've had the benefit of being at Intel for a long time and at HPE and all of these companies. So, how do you see this, the convergence of HPC, AI, quantum, playing together? Like, what is your observation been?
Well, I think in terms of like how supercomputing, like the definition of supercomputing is evolving based off of these, one of the biggest takeaways I had coming out of SC this year was, typically we've measured supercomputers in performance, and there was someone who earlier this year, and I can't recall who it was, but I said, we're the only industry where flops is actually a good term, and we want to talk about that in a positive way. What I've seen now, though, is yes, performance is still king. However, the actual, what we call good put in the work that's coming out is actually really now the measure of success here. And so I think that's how the definition of supercomputing is evolving. And then I think it's also, to what Annie said and kind of what we addressed in the previous question, you're going to stop seeing those silos of HPC, AI, and quantum, and you're going to start seeing more of these kind of heterogeneous systems where these are now, all of these things are working together to solve, again, going back to that good put, getting to time to insight faster. And there's going to stop being these silos between what is AI versus what is HPC versus what is quantum. To address your other question, though, on quantum, I may be a little bit more conservative. I think it's probably in the 10 plus years before we start seeing practical applications. And that actually might be too aggressive even. Someone put in the chat kind of 5 years from any given date. And I think that's probably the best we have to go off of right now. And HPC's just changed. It's become, the democratization of HPC has really helped a lot. What was when I was at HPE, it was still we called it we were breaking out of labs and academia and we were going to enterprise, and I think we're still on that journey a little bit, but not as much. There's obviously quite a bit of enterprise adoption of HPC, and I think we're only going to still see that it continue to expand. You know, HPC is everywhere, supercomputing is everywhere. It's really about what are you using it for.
All right. Okay, and Wyatt, you've been solutioning at Google for a long time. So what does this mean to you when you see, you know, somebody talk about this convergence?
So yeah, I think Annie hit on it earlier. I think that I think quantum computing is going to sort of drive the conclusion of what we're seeing right now with AI, where we're seeing a merging or sort of a coalescing of the stack between HPC and AI, and quantum, I think, would drive that to its full conclusion, because AI demands a lot of GPU power, generally a lot of accelerator power of some kind, and that generally requires the cloud to get access to, unless you're a very large scale customer. Quantum computing will be out of reach for most people, except for maybe some small desktop cards. So that, if you wanted to use quantum computing, you would absolutely need, some remote resources, whether that's a commercial cloud provider or a specialist provider. So I think that's going to drive the assimilation of a platform across HPC AI and quantum, across on-prem and cloud. And whether that's Kubernetes or some other technology, I think we're going to see that moving quickly. And I kind of have some pet theories. If I took my background off, you'd see all the red string tied up between NVIDIA and Slurm and DGX Cloud, and what their plans might be in terms of building a sort of one platform to rule them all across GPUs and clouds and whatnot. But we'll see about that. I also like Seth's answer in terms of 5 to 7 years, but maybe I'm biased, and I'm because I'm sort of invested in quantum computing companies. But that's a great answer, 5 to 10 years.
Is it like, always going to be 5? It's 5 to 7 years from being 5 to 7 years away.
That's perfect answer, as long as the stocks keep going.
Yeah. All right, Annie. I think Annie wants to chime in. So, Annie.
Annie, you're on mute.
I'm on mute. Sorry, I took my hand down and I didn't unmute myself. I just wanted to build on something Wyatt was saying around when we think about convergence, something I'm seeing is customers wanting to use the same hardware for both training and inference, and wanting auto scaling for that cluster. And as Google, as an HPC solution and product provider, we're trying to meet the customer where they want simplicity, where they want convergence. They don't want to manage the underlying hardware. And so that's been a really cool problem for us to start solving with things like Slurm, Slinky, GKE. I'm thinking about combinations of GPUs and TPUs in the cluster. Happy to talk more about it. But I also saw there's a question from Horst around Genesis. I actually am not that familiar with the project. Is there someone on the call who would be able to speak more to it?
It's the executive order about AI.
Oh yeah.
Oh, right. It was right. It was the EO.
Right, from the White House on Genesis. Yeah.
So actually, I do have thoughts about this. Is it okay if I continue?
No, please go on. Yeah, go on.
So I think Genesis really validates our AI-first HPC stack approach for Google Cloud, which is something we've been developing for some time with products like Cluster Toolkit, Cluster Director. We've been talking about cluster as a service. We've been talking about how for AI and HPC workloads, which were previously siloed and separate, that the cluster characteristics are similar enough, are in fact the same in many ways, that we should be delivering the same products for them, and we should be optimizing the same way for them. And this was something that internally, I won't bore you with the details, but sometimes there was some friction around, how we actually converge the architecture. And over time, we were able to, with Bill Magro's leadership, he's not on the call today because he's traveling, but he was able to really champion that view and move forward with concepts like the AI hypercomputer and Cluster Director. And so I see I see Genesis, excuse me, G word, as really a validation of what we, Google Cloud, have been striving strategically to deliver for HPC for some time. And so we're very excited to meet the US government where they are now in terms of their requirements. And I know we have a number of internal discussions, which I unfortunately can't share, but we are excited to see it.
All right, cool. Thank you very much, Annie. All right, so let's move on now. So, you know, all of you, or many of you are familiar with Gemini. You know, we use it every day. I think I would almost be guilty of using it too much, as I'm sure Bill would probably, you know, tell me. But, you know, as a researcher or a developer, you know, how are you using Gemini? Right? You know, how do you see it sort of playing into your workflow and for analyzing results? So very quickly, Annie, like, you know, let's start with you. How are you using Gemini today? You know, and talk about, you know, where it's really good, and also, you know, where you feel it's not up to the mark.
So I am also using Gemini a lot, Adnan. So I don't think you are guilty at all. In fact, I think it's actually something that's helping speed up not just volume, but also time to insight for us as product managers. The way that I see it being most helpful for me in my day-to-day is around analyzing results. So often before, I would have a number of data sets, a number of questions, and I would have to you know, book chunks of time to go and create the analysis for it. And that would, you know, necessarily be kind of fragmented throughout my week. And I would have a lot of like, you know, not tech debt, but data debt in a way to get to the insights that I need to drive the strategy we're creating. Now with Gemini, I really think of it as like a junior analyst or even a junior PM in how I can direct it to do certain research activities for me. It can, you know, sift through mountains of data and then even interrogate that data. We can go back and forth about it and present me with some hypotheses that we can test. And so I'm really thinking of it as a like first draft creator, as a junior analyst, as something that I can rely on to kind of co-ideate and co-create. Talking about researchers and developers, the immediate benefit I'm seeing for Gemini there is really around code optimization. And so speaking with a lot of my FSI customers, they're using Gemini, and also to be fair, ChatGPT, you know, the other models out there are also being used this way, ChatGPT and Claude, for code optimization. And so they're generating code with it. They're addressing code errors with it. They often are actually putting their code that they've written into it and asking for it to be improved. And we're getting a lot of healthy and helpful feedback from customers testing Gemini 3, which is a latest version that we released just a couple weeks ago, about how it can be improved further. I have heard actually very positive feedback about Gemini 3 for folks who have not been able to use it. I highly recommend it. It's what we dog food internally. And I've seen a huge improvement generation to generation. But yeah, I certainly use Gemini frequently, I would say daily, in my workflows as a product manager. I find it very useful. And then I'm also hearing positive feedback from customers about it.
Yeah, that's wonderful. And again, you know, I use Gemini for all kinds of things. Gemini CLI, thank you very much for pointing that out, Darmuid. You know, we had a whole, for those of you who are at Supercomputing, we had several demos that featured Gemini CLI for automating everyday HPC tasks. So if you're interested in that, feel free to reach out to one of us. Happy to show you those demos. But Megan, now you've got a slightly different perspective on this. You know, how do you see Gemini and Gemini CLI factoring into your daily work?
So I actually refer to Gemini as my best friend on any given basis. It's incredibly helpful in just, I mean, as Annie said, kind of automating and researching some of the tasks. One of the areas that I found it, two agents that I found kind of incredibly helpful within Gemini Enterprise are Deep Research Agent and then the Idea Generation Agent. So Deep Research is kind of you call it like your own personal notebook where you can upload sources and then you can query against those sources. You can even use it to create podcasts of the data. Jay told a story last week, I think, of someone who has been uploading our weekly sessions into it and creating 15-minute podcasts of it. So instead of watching the hour-long YouTube, they're getting a 15-minute podcast. It can also create one pagers, like visual one pagers of the content. And it really is just kind of a helpful tool in helping to summarize some of the data. I think, you know, we are all inundated, whether you're a Googler or you're external, you know, there's so much information out there. And so being able to sift through it in a very kind of comprehensive and consumable manner, it just saves time and energy across everything. The other tool that I really like that I've used is the idea generation agent. And it just, it is something that we use to help kind of evaluate, propose, and then rank some novel hypotheses. And so I'll be, you know, one example of how I use it in terms of outbound is when we were creating supercomputing demos and what's going to be most interesting. And I asked, you know, help me create the most appealing SC25 demo that captures how we're using dynamic workload schedule to then go kind of revolutionize in scheduling, HPC job scheduling, and it comes up with neat ideas. And it's, if you haven't used it, go back, and I can also send some pointers here in the chat. It is amazing to help kind of go and ideate on it and really drive that knowledge. I think the Code Assist and Gemini CLI, I played with them a little bit, probably not to the same extent as you, but they really are. I think there's Bill put it up in the chat, I believe here. It's there's still a human element to it, though. It's great to help ideate. It's kind of your partner in crime. That's why I like to call it my best friend. But I don't rely on it, you know, in and out as everything. There does have to be that extra kind of oversight from a human that helps build this process.
No, that's very true. It's very smart, but it still needs a lot of guidance. So Wyatt, as you know, as a product manager, as a longtime Googler, you know, have you seen it changed? Have you seen Gemini get better, and how have you been using it?
Gemini's definitely gotten a lot better. I still think about a lot when it was called Bard, and when it was yeah, a much weaker product, and something that I wouldn't have relied on for very much. I use it a lot for the types of things that Annie mentioned, especially in terms of data processing. It's very good at going and augmenting data that you might have with publicly available data that I can go and find on the web. I'm going to play a bit of devil's advocate, though, in terms of you know, human in the loop part of what everybody was just saying, and say that Gemini CLI has something called YOLO mode.
Yeah.
I'm sure everybody knows what YOLO means. You only live once, but basically you can turn off all of the confirmations and checks that Gemini CLI would normally ask you for. Where, if anybody's familiar with Gemini CLI, it'll say, you know, yes, allow this once, or yes, allow this every time. You can turn that off entirely and just let Gemini CLI do what it thinks is right. And that is a very, very powerful thing for longer running tasks. And I've had a lot of success, especially recently, in very clearly scaffolding out projects, making full markdown files of plans, of stages of development, of implementation strategies, and all these sorts of things, but then letting Gemini CLI go off and just do it stage by stage. So it is a lot about the prompting, but you know, once you set it on the right path, Gemini is very, very, very capable, and is getting even better about correcting itself and realizing when it's making a mistake, or when it's made a mistake that it thought was the right thing to do. So I've been able to develop some, you know, silly games. I developed a Chrome extension just recently to automate a sort of menial task that I would like to do regularly. So it is a very capable platform, and I think you know, I'm starting to really see this sort of era of personalized software coming to a reality where I think people are going to be able to build an app or an extension or whatever it is very, very easily to do exactly what they want to do. And that some of these apps, you know, that are popular in the market might lose popularity.
All right. Thank you very much, Wyatt. Megan?
Yeah, one thing maybe just to follow up to what Wyatt said, I think what I've seen is what your output's only as good as your prompt. And so I actually think you're going to see a lot more prompt engineering and other things like that, you know, in the there's a lot of, instead of maybe learning the tools and applications in school, you're going to be learning about how to write the perfect prompt, and that's going to be how you get the good data. And so I think that's going to be the biggest probably change is that we see here in kind of the terms of what's coming next.
Right. Okay. Yeah, and and actually something that Wyatt said, the YOLO mode, I think is incredibly powerful. And for those of you who are not familiar with Gemini CLI, again, I'd encourage all of you to try it. And you see a lot more of that agency or that agentic capabilities coming out when you give Gemini CLI a task to do, which, to me was a revelation, because when you ask Gemini, just the web interface a question, it gives you the answer, it gives you all the analysis behind it. But you will really see that agentic qualities play out when you use Gemini CLI and ask it to do a particular task. All right, okay, so time check, we've got, a little under, 20 minutes. I'm going to try to move quickly, but here's a question for everyone. Okay, so in terms of actually, you know what, I want to do something else before we get over here. Oh, actually, I don't see my questions. Okay, anyways, let's the question I had is and this is, for everybody in the audience, please type out your questions in the comments. If you were to pick, what is the most overhyped technology in HPC right now, what would it be? So I'll just give you a minute, just type it out in the chat. And the question again is, what is the most overhyped technology in HPC right now? So let's get a few comments going. Okay, I see quantum sensing from Brian. Who else? And again, the question is, what is the most overhyped technology in HPC? I'm sure you've heard, some things more often than others. So whilst we're waiting for people to put in their comments, let's get into RAM prices. Yes, well, that is definitely, yeah. I was trying to build myself a computer, and the RAM prices are killing me. All right. Okay. As we move on, okay, just again, for the audience, this is really, the objective of the community is we want to bring in topics that are relevant to you. What are you interested in? What are you working on? So we want to make sure that as we come up with our agenda and our schedule for next year, we have an opportunity to address some of those places where we can do better or we can do more of. So if you've got a topic in mind, put it into the chat, and we will definitely make sure that we have something that aligns with that particular topic. Okay, and I see Belinda's talking about InfiniBand at higher speeds. So is that a topic suggestion, Belinda, or is that is it overhyped? Okay, so it's overhyped. All right. Okay, so moving on, one of the things that's obvious is, AI is definitely making things simpler, but it's also making things more complex. There is a step function in terms of what you need to know to get started. And upskilling and training is a topic that Google takes very, very seriously, and one that we're all trying to address. So the question is, what are some of the initiatives that we have at Google Cloud that help upskill the workforce and to train the next generation of HPC engineers? Like Annie, you've been working with several customers, several companies. Some who are very, very familiar with HPC, some probably not as much. So how would you answer this question?
Yeah, this is a really great question, because I would say it's like top of mind for my financial services customers is talent shortage and building a pipeline of talent to meet the demands of their HPC and AI workloads. So I'd say as Google Cloud, we're doing probably 3 things for this. The first is the democratization of HPC through the simplification of setting up these systems. So we have the cluster toolkit, which translates what previously was a very complicated cluster setup into something that's more of a classic cloud DevOps issue. And so you can take a more generic cloud engineer at a bank and have them work on building a cluster, managing a cluster using tools like our cluster toolkit. It's available as a GitHub repo, open source. I highly recommend, if you guys are not aware, to look it up and try one of our quick starts for setting up, for example, a Slurm cluster with a cluster toolkit. It's really meant to make things fast, easy, and quick for anyone to get started, and then also to enable larger system admins and teams to run their clusters as well. The second thing that we're doing is around curriculum. So we have a number of HPC and AI modules in our Google Cloud Skills Boost that we've already built, and then I think we have plans to update in 2026 as well. We have a number of HPC days that we'd like to run in person, and we have the GCACC events too. And these are opportunities to work directly with Googlers and also to work with Google created content to again build your skills. And the third one, I know that we've already talked about a lot, but AI is really, I think, helpful here. Gemini is the best co-pilot for a lot of these questions that we haven't even created curriculum for. And so really, I think everyone needs to use AI in their everyday work because it's here, we're adopting it. And also it's very useful. I found, like, I was initially skeptical with the earlier generation models, as Wyatt mentioned. I remember Bard early on, like trying to use Bard and then being like, forget Bard. But as things have improved, I've noticed that I'm using it more and more. And so the other way that we're helping is, giving our customers a upskilling tool in Gemini that they can use to translate legacy code, they can use to debug errors, they can use to learn about new concepts, and shorten that ramp up time.
Yeah, and in fact, as I was coming up to speed at Google, one of the things I relied heavily on Gemini for is trying to deploy a cluster. Just walk me through the various steps of deploying a cluster and using cluster toolkit and so on. So for those of you, again, if this is something that you've been looking to do or interested, Gemini is a great resource for that. So Megan, tell us about what everything that's planned for in the coming year for training and upskilling and things like that. Annie talked about the HPC days. Could you elaborate on that?
Yeah, I mean, so if I kind of looking at the question, I think this community is actually the biggest initiative we have for working to upskill the workforce and train the next generation. That is, so we'll continue to have the weekly webinar series and continue to see this grow. For those who didn't notice, we did start bi-weekly. Now we've moved to weekly because we do have such good content that we can share. The biggest thing though is this will spin out. We started a few of them this year, but you'll see us get much more aggressive next year is on these in-person workshops. So both in terms of HPC days, as well as some of like the hands-on lab sessions that we've already begun. And so I think actually a few, maybe 3 or 4 of our in-person workshops that we're planning as a community are posted on the webpage today to sign up. We're going to be also, we've done 2 in Austin. You're going to see us take our game on the road in 2026. We're going to be in California, New York. We'll continue to do some here in Texas. But you'll just see us diversify our locations. And this is going to be places where you can really come and learn not only about what Google Cloud, I mean, there will be some basic kind of the HPC, AI, and all these things, I'll call it 101, but then really also being able to dive hands-on into these activities and play with some of the labs that Wyatt's put in here, go through how to deploy a cluster, how to run an application. And so you're going to see us be much more aggressive and just have much more of a predictive cadence on these workshops and training. The other thing we're doing is we're really working to enhance our documentation. Annie and I both have kind of spent some time. Our documentation can be somewhat fragmented. Really being able to go and put it into one consumable place is a big initiative for us that it makes it easier to get on Google Cloud as well as to learn about our offerings and capabilities. So that's something else that you can expect to see.
So there's a great question from Brian on the comments, and what are we planning for South by Southwest, Megan?
So we'll probably do similar to what we do. I know we'll have some folks who are participating in the actual South by Southwest sessions. Last year, we did kind of an ancillary event at the Google Cloud Austin facility when we hosted a workshop there. I would expect that we'll do the same thing, and we'll be probably starting to promote that and send out invites here pretty shortly. So probably expect another, yes, we are less than 4 months out. Don't remind me. Brian. It's everything's coming up too quick, but we will be doing these. We'll expect to see a workshop around that time. And then the workshops are for all skill levels. I mean, some of the hands-on portions do require a little bit more expertise, but candidly, I've seen kind of all skill levels being able to run through them successfully. And we do have experts there who can also help.
Hey, Brian, please let us know how we can participate. We'd love to have a Google panel available for you at the Red ThreadX. Wyatt, so yeah, feel free to reach out to Megan, myself, or anybody on the team over here, right? And Wyatt, you've created some excellent, quick labs and tutorials over the course of many years. So what are your plans for next year? How are you looking to enhance the content we already have, or create new content and make it more accessible?
Yeah, 100%. So one of the things that I don't think has been mentioned explicitly yet is tutorials and workshops at third-party events. We are definitely submitting for tutorials and workshops at major HPC and industry events. So pending approvals, which we're hopeful for, we think we have a really good slate of workshops and tutorials that we're submitting. Keep an eye out for us, hopefully at shows like ISC and SC. But also others that we can definitely share on the community website as we lock in our sponsorships and workshop plans and everything like that, as well as our HPC days. So yeah, we're trying to get ourselves not only involved in hosting workshops that Google hosts as Google, but also as part of technical conferences where we can expand our reach.
And again, just to add on to what Wyatt and Megan and Annie have said, we do spend a lot of our times trying to enhance our training and content. So if there's, we can host a workshop for you, please let us know. We'd love to do it in person if possible, but definitely online as well. Okay.
So, I would just add, for anybody, especially at universities who are interested in specific trainings around things like AlphaFold, we have specific workshops that we can bring to you regarding specific workloads, not just, as somebody said earlier, just spinning up a Sloan cluster. We could certainly do that if that's helpful for your for your teams, but we could also go into industry use cases and sort of day two operations and these sorts of things.
Right. Okay. All right. So we've got around 5 minutes left, so I'm going to ask one more question. And this is really, again, sort of very much in line with our previous topic is, what is the best first step for moving your workload into the cloud without disrupting your current R&D pipeline? Annie, you've probably helped with many of these, so can you comment on this one?
Yeah. So my customers often start with benchmarking or a POC, and what they're doing is they are kind of testing the waters, but they're also getting to know cloud concepts. So things like elasticity, on demand, being able to scale up and scale down are not concepts that are as useful for on-premise. And so the first thing we want to show people is that they have that ability to dynamically scale up and down quickly to the size of cluster they need and then back down. And so we often will run a benchmark or a synthetic workload that approximates something they're running on-prem, or we'll even just start with a POC, bursting to cloud for a hybrid setup. And so I think that's a good way to get things started. And we actually have a lot of tools like Cluster Toolkit, like our HPC VM image, our Slurm GCP offering that can assist with that benchmark and POC. And we also have a number of teams here to help you as well. So if you're in financial services and you're interested in running these, please let me know. I have a team that I can help support, that I can deploy in terms of engineers and PMs. And then we also have a number of partners that we work with. We haven't really talked about that, but we have a vibrant and large ecosystem of partners that we can bring to bear to help with benchmarks and POCs too.
All right, and again, just to add on to what Annie said, just as Annie has FSI covered, we've got other PMs that are focused on manufacturing, on EDA, on public sector, and so on. So again, no matter what domain your problem is, we probably have somebody assigned who can address that. All right, I'm going to quickly pass it on to Earl since he's got his hand up. Earl. Earl, if you'd like to unmute yourself, you can speak directly.
There we go. Can you hear me now?
I can, yes.
Hey,
I was
excellent.
hoping you'd have a comment or something today because I saw your written comment in the chat.
Sure. So, we do all the surveys of lots of buyers around the world and everything. And the first thing that always comes up here is testing new hardware that you don't have, or new software, new approaches, and we recommend that clients, who haven't used the cloud or much, that's the first step. Don't go out and buy expensive hardware. Try it out in the cloud, see how it works. The next thing we tell them is look at your whole workload profile. And certain really hard jobs or classified jobs or jobs you really need to keep on-prem, you can put those off to the side, but look at all the major workload, which is usually a large set of smaller jobs. Start running them in the cloud because it frees up a lot more time for your other workloads. And then the other thing that Anna mentioned is scale. If you want to really start doing some AI work and doing large models and everything like that, you may not be in a position where you're going to do that every day, or every hour of every day. So buying an on-prem system would just be a waste of money. So go try running some big things at scale and see how you can advance your science, do things differently, and then slowly make a move forward. And that seems to resonate with most of the clients that we talk to. So I just want to add that.
No, that's great input. So thank you very much for sharing that with us, Earl. Okay, very quickly, Megan, Wyatt,
I put my comment in the chat. I mean, I think the first step is really to look at your workload and evaluate what can, should move, and what makes the most sense. So, I mean, kind of similar to what Earl said.
All right. Okay, Wyatt?
Yeah, we always recommend, just as Annie said, finding that workload that makes the most sense to move, that maybe has the largest need for whatever reason, or that is the most isolatable from the environment, and move that to cloud. Do it in a way in the cloud that you would intend to do to run other workloads, to implement your authentication, your storage strategy, whatever it is, and get that one workload running as best as possible, and then slowly onboard more and more until you have the right balance between cloud and on-prem or cloud and other clouds, whatever that might be.